Okay, here we go, Unit 6 study guide. So next problem, or next page for all the problems, and please do the work. At the end of the study guide, ask yourself the 3 questions below. If the answer is no to all 3, then the bottom line is you need to increase your work ethic because geometry ain't easy. So first question, did you master all these problems before taking the test? Hopefully. Did you call a friend to study or ask for help once you were stuck? Did you email Mr. Fisher with questions or just watch this video? Hopefully you say yes to all 3. Here we go. Graph the circle. X plus 1 plus y minus 3. Well, they're both squared. So x plus 1 squared plus y minus 3 squared equals 16. So this is in the format that you need. So in just looking at this, you know that the center is going to be -1, 3. So whatever zeroes these out. So -1, here's -1, 1, 2, 3. There is your center. Now your radius is going to be 4. So the radius will be 4. Wow. I'm going to have to do some compass saving. My compasses are in terrible shape. Okay, so we got to get a radius of 4. So we're going to go this. That pretty much nails it. Okay. So I'm trying my best here. Pretty good. Okay. So there's how you do it. Radius of 4. Center there. All right. -1, 3. Find the distance from the center of circle to each point on the list. So 2, 1 is known as I. 4, 1. So let's label them 1, 2, 3, 4. Is double I, and then 3, 3 is I. So here we go. From 3, 3 to -1, 3. Well, I know that is 4 units. So 4. 4, 1. Let's see here. How can we figure that out? Well, what would you do here, or what you would do here is draw a right triangle. That's my favorite way to do these. So let's do 4, 1. We'll do 4, 1 in red here. Okay, so we got to find the point to I. Now, you got a right triangle. This distance is 1, 2, 3, 4, 5. This distance is 2. So to find the distance from the center to I, you just go like this. 5 squared plus 2 squared equals C squared. right? Because we got a right triangle. So 25 plus 4 equals c squared. So 29 equals c squared. Take the square root of both. So this distance is the square root of 29. So square root of 29. Now let's go to this one, 2, 1. So for this, I'm going to use green. It's still 2, but this one is 3. So to find this distance right here, you're going to say 2 squared plus 3 squared equals c squared. So 4 plus 9 equals c squared. So c squared will equal 13. So this one's going to be the square root of 13. I'm just using Pythagorean theorem. So for the green, square root of 13. This one's square root of 29. So if you want to write that in, square root of 13, square root of 29, and then the other one was 4. So C asks you, what do these distances tell you about whether each point is inside, on, or outside the circle? So I, up here, 2, 1, is inside. I, 4, 1, is outside. And I is on. Easy. Why do I know I is on? Because it's the same as the radius. Because the radius equals 4, so that happens to be 4. So that point is on the circle. Okay, number 5, reflect triangle ABC over the line y equals 2. Okay, no problem. So let's draw y equals 2 in red here. So we got to reflect over y equals 2. Pretty simple. Just count 1, 2, 3. 1, 2, 3. That's going to be B prime. Let's look at C. 1, 2. 1, 2. There's C prime. Because A is on the line of reflection, that's just going to stay there. So I'm going to use a straight edge. To draw these. All right, there you go. It's that shaded triangle. Okay. Translate the image by the directed line segment from 0, 0, right here, to 3, 2. So all points then go 3 units over, 2 units up. So 1, 2, 3, 1, 2. That's going to be A double prime. 1, 2, 3, 1, 2. That's going to be C double prime. 1, 2, 3, 1, 2. That's going to be B double prime. And we are going to connect our dots. The green triangle is the reflected and translated version of ABC. What are the coordinates of the vertices in the final image? Well, vertices are the points. So A double prime, B double prime, C double prime. A double prime is -2, 4. Negative 2, 4. B double prime is negative 3, 7. And C double prime is 0, 6. So we did everything. We're done with that one. All right, to the next one. Here are some transformation rules. For each transformation, first predict what the image of triangle ABC will look like, then compute the coordinates of the image and draw it. Okay. So, first one, x, y, x minus 4, y minus 1. So, let's go start with A. X is going to go 1, 2, 3, 4, because it goes minus 4. And y minus 1. So there's A prime. We're going to do red, green, and blue. Okay. B, minus 4, minus 1, right? 1, 2, 3, 4, minus 1. Here we go, B prime. C, 1, 2, 3, 4, minus 1, boom, C prime. Connect the dots. Okay. Second one's in green. Okay, this one I'm going to use some... This one was so easy I could just visually do it, but I want to do A, B, C on this next one. And this is always a good idea if you can't figure it out. We're going to call these double primes because it's the second one we're doing. But and these are all going to be our green one. Okay, so A, X, Y. So X becomes the Y, Y becomes the X. So A is 2, 3. B is 4, 2. And C is 3, 5. Now, I prefer to go this route because it's too much thinking to do this visually. But the 2 becomes the Y. The 3 becomes the X. So the X becomes the Y becomes the X. So you just flip these. So 2, 3 becomes 3, 2. Remember, the X becomes the Y becomes the X. The X becomes the Y becomes the X. Now let's plot these. So 3, 2 is right there, and that's A double prime. 2, 4, 2, 4 is right there, and that's B double prime. 5, 3 is C double prime. Connect our dots. Okay, there they are. All right, now this one is negative 2, 2. This is 0, 1, and this is negative 1, 4. Because I almost missed the coordinates on that first one. Okay, so the green one is right here. All right, now let's do blue. Oh, man. All right, so we've got A, B, C, comma, 2, 3, 4, 2, and 3, 5. Now we've got to do this rule coming up. We're going to call these triple primes. Why? Well, I don't want to confuse you. But anyway, the rule is we got to multiply each of these by 1.5. So x, 1.5x. Okay, so 2 times 1.5. So 2 times 1.5 is 3. 3 times 1.5 is 4.5. Let's do that again. 4 times 1.5 is 6. You might need a calculator for these. That's okay. 2 times 1.5 is 3. 3 times 1.5 is 4.5. 5 times 1.5 is 7.5. Now you plot them. 3, 4.5 is right here. Ooh, it's getting busy. We're going to call that A triple prime. 6, comma 3 is B triple prime. And 4.5, 7.5 is actually off the grid right there. And that is C triple prime. All right, getting a little complex here, but that's okay. A triple prime. There's a C triple prime, B triple prime, and there's a B triple primes. Okay. So there's the graph and the coordinates. I wrote them in for the red one. Challenging problem, no big deal. Okay, graph the circle. X minus 2 squared plus y minus 1 squared equals 25. So your center is going to be 2, comma 1. So 1, 2, 1. So there's your center. 2, 1. This is the same as 5 squared, and that's how you figure out the radius. So the radius equals 5. And we got to graph it. So here we go. 1, 2, there we go. We should do her. Okay. Compass is the easiest way. For each point, determine if it is on the circle. If not, decide whether it is inside the circle or outside of the circle. Now, if it's obvious, we're just going to make a quick decision. 4, 0. 1, 2, 3, 4, 0. Inside. Negative 3, 3. 1, 2, 3. Outside. Negative 2, 2. I'm going to say inside. So if you can draw a graph with a center and a radius of 5, and you can use a compass, you will save yourself so much time. Otherwise, you have to figure out the distance from the center to each of the points, which, who wants to do that? It's a lot of math. Hey, maybe you do. That'd be cool if you did. But the easiest way is just to graph it and use your graph to figure it out. Now, if they give you a point like negative 2, 4, so 1, 2, 3, 4. If they were to give you negative 2, 4, it looks like it's on the circle. You'd probably want to run it. So negative 2, 4. How could you figure out if negative 2, comma 4 is on the circle? Well, you could just use the formula. X minus 2 squared plus y minus 1 squared equal 25. Let's see if it works. So negative 2 minus 2 squared plus 4 minus 1 squared, does that equal 25? Let's find out. Negative 2 minus 2 is negative 4 squared plus 4 minus 1, 3 squared, does it equal 25? Let's find out. 16 plus 9, does it equal 25? Yeah. Does 25 equal 25? Yep. So negative 2, 4 is on the circle. So you could just run it and figure out if it's on the circle. It's an easy way to do it. You could also compute the distance like we did earlier. So like, for instance, you could draw like a right triangle and do it that way, which is technically how you get the formula for a circle, which is pretty sweet. But you just count them: 1, 2, 3, 4. 1, 2, 3. And that's a 3, 4, 5 right triangle. So yep, -4. -2, 4 right here is on the circle. All right, number of ways you can figure those out. How can you use distance calculations to decide if a point is inside, on, or outside of the circle? Okay. Well, if you find that the distance from center to the point they ask equals the radius, then the point is on the circle. So if you find the distance from the center to the point they ask equals the radius, then the point is on the circle. Kind of like that example. All right. Okay, next question. Here we go. Write an equation of the line that passes through 1, 3 and has a slope of 5/4. So you want to use what's called point slope formula or form for this. And I'll show you why. Point slope form is awesome. It's this form. Point slope form is y minus k equals m times x minus h. Here's m right here. This is m. 5/4. Watch how easy these are. You just got to plug in whatever zeros. So since it's +3, you just go y minus 3 equals 5/4 x minus 1. It's that simple. It's tricky when they have like negatives. If you see a negative, then you just throw a little plus sign on there. Mr. Fisher is visiting the city of Geometropolis. Geometropolis, shown below. One day he goes to the swimming pool to relax with his friends. Okay. After they are all hungry, but after swimming all day, they are tired. Fair. Okay. Swim all day, you're going to be tired. Mr. Fisher says that it doesn't matter if they go to the food store or the cafe because he says they are the same distance away from the swimming pool. All right. I see what they're doing. Triangulation. It's a swimming pool right here. You got to get the coordinates. Swimming pool. -3, -1. Okay. Food store. 5, 1. And cafe. Where's the cafe? 2, 3. Maps, like the Apple maps, are all on a grid. I don't know if you knew that. Anyways, it's when you get into spheres that it gets a little tricky, but here we go. Is Mr. Fisher correct? So Mr. Fisher's always correct. Just kidding. So swimming pool to the food store. I make mistakes all the time. Seriously. Versus switch colors. Swimming pool to the cafe. Looks like the food store is further, but you can't just say that based on looks. You got to prove it because sometimes you'll be surprised. So let's figure out the distances. And you do that by drawing your right triangles. Okay. It didn't really help much. We're going to do them all in red. If you can learn to draw ideas in helpful ways, you'll be ahead of the game. All right, let's do this one. Okay, so we're gonna set up some right triangles. Okay, so what's closer, basically, right? All right, connect the dots with the line, draw your right triangles, run Pythagorean to check the distances. Okay, so -1 to 1 is 2 units. Let's count them off, they're all 1. 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's count these ones. 1, 2, 3, 4. Let's count these ones. 1, 2, 3, 4, 5. Okay. So we got a couple C's here. Call that one C prime. All right, so this one, the blue line, the blue hypotenuse, we're going to call C. The red hypotenuse, we're going to call C prime. All right, so to find the distance from the pool to the cafe, you just run Pythagorean. 4 squared plus 5 squared equals C squared. To find C prime, you're going to say 8 squared plus 2 squared equals, we'll just call it C again. I'm going to color code it. I don't want to call it C prime squared. Anyways, you're color coding so you don't confuse your fragile brain. All right, so 4 squared is 16 plus 25 equals C squared. Here we go. 8 squared is 64 plus 2 squared is 4 equals C squared. 16 plus 25. 25 plus 10 is 35 plus 6 is 41 equals C squared. 64 plus 4 is 68, which equals C squared. So this one is the square root of 41. This one's going to be the square root of 68. Do you even have to compute them? Not really, but let's do it anyways. Might as well. So just to be clear, for the blue, from swimming pool to cafe, is second x squared 41, which is 6.4. And then we're going to go second x squared 68, 8.25 equals C. So are they the same distance away from the swimming pool? No. The cafe is not the same distance away from the swimming pool as the food store. Food store was in red, remember? Cafe was in blue. The cafe is 6.4 units away, and the food store is 8.25 units away. Since they're tired, they should go to the cafe. All right. Since they're tired, they should probably go to the cafe. Unless it got bad Yelp reviews, right? Little joke for the day. Yeehaw. All right. Oh, next one. Select all the equations that represent the graph shown. Woo! This is a tough study guide. Okay. Here we go. Rise over the run. Start there. Use these 2 points. They're all 1 unit, so 1, 2, 3, and 2, right? So the rise over the run equals 3 over 2. So let's figure out which ones have 3 over 2 as a slope. Oh, great, they all do. Okay, so, well, maybe. We got to change this to y equals mx plus b. So we're going to have negative 2y equals negative 3x plus 6, and then you divide by negative 2. So you'll have y equals 3 halves x. 6 divided by negative 2 is minus 3. Okay? So that's this one. So just cross this out. Y equals 3 halves x minus 3. Okay. So some of these are in like y equals mx plus b form. So they all have a slope of 3 halves. So we weren't able to rule any of them out. Negative 3, let's see, negative 1, negative 2, negative 3 is the y-intercept. This one is good. All right. 3 over 2 is the slope, right? Okay. Is positive 3 the y-intercept? No, don't circle B. All right. Y equals 3 halves x minus 3. That's just this one rewritten. We already did that work up here. So C is good. All right, let's go to D. Slope is 3 halves. Does the point 4, 3 lie on this line? 4, 3. Let's see. 1, 2, 3, 4. 1, 2, 3. It does. D is good. Okay. 3 halves, we already verified that, so slope's good. Does the point 2, 6 lie on this line? 2, 1, 2, 3, 4, 5, 6. Nope. So your answer is A, C, and D on that one. Yee. All right, a triangle is made up of the points S, negative 9, 0. There's S. I'm going to draw it real big. Negative 3, 4 is I. And L is 1, negative 2. S-I-L. Why did they choose that? Okay. Prove this triangle is a right triangle. Oh. Oh, oh. So they are saying this one right here. Is this puppy a right triangle? Wow. That is a tough question. Obviously, it would be this one if it were a right triangle. Now, use math evidence. You could get the distance of A, B, and C. And then if A squared plus B squared equals C squared, then it is a right triangle. That's the converse. That's known as the converse of Pythagorean. So you could go that route. You could get all these distances and see if A squared plus B squared equals C squared. That's option 1. But there's an easier way. The easier way is to determine the slope of this line and compare it to this line. Because there's a concept. So option 2, perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. Oh no, is my favorite pen going out on me? I think it is. So perpendicular lines have opposite reciprocal slopes. Opposite reciprocal slopes. So like, here's an example. If one slope is 2/3, the other one has to be -3/2. So we're just gonna run the rise over the run here to get the slope of SI. The rise, 1, 2, 3, 4. The run, 1, 2, 3, 4, 5, 6. Confirm if that's right. Yeah. So for the SI slope, go rise over run. This is why writing on your figure is so important. Rise is 4, run is 6. Or, in other words, rise is 2/3. 4/6 is the same as saying 2/3. Now, if I go IL's slope, you're going to ask yourself, question mark, does it equal -3/2? Okay? Because we're using this one. If it equals -3/2, these two lines are perpendicular, meaning that that's a right angle, meaning that this is a right triangle. Yeesh. All right, let's do it. Here we go. Let's go. Rise. Run is right here. Now you gotta be careful. Run's negative. Rise is positive. So rise, 1, 2, 3, 4, 5, 6 is the rise. Run is -1, 2, 3, 4. -4. So IL's slope equals the rise over the run, which in this case, the rise is 6, the run is -4. Does that equal -3/2? It sure does. So since SI slope equals 2/3, so because SI slope equals 2/3 and IL slope equals -3/2, these two lines have an opposite reciprocal relationship, meaning angle SIL, so angle SIL equals 90 degrees because SI and LI are perpendicular. So the question in the beginning asked you, where did I just put it? I had it written somewhere, right here. If this is a right triangle, SIL. Yes. Triangle SIL is a right triangle. Fun, huh? That was a lot. Jeez. Oh well. All right, find the perimeter, the distance around the triangle. These jerks, it just never stops. All right, so SI squared, that's the hypotenuse, right? It'll equal 4 squared plus 6 squared. So SI squared will equal 16 plus 36. SI squared will equal 46 plus 6 is 52. So SI will equal the square root of 52. All right, so that's square root of 52. Fair enough. Okay, let's figure out this one. 6 and 4 again, those are the distances, so we already know this is square root of 52. Oh, we got a isosceles right triangle. Okay, so that and that are both square root of 52. So IL equals square root of 52. Now you got to figure out SL. And SL is a hypotenuse of a right triangle. So SL squared, the hypotenuse, like C, will equal square root of 52 squared plus the square root of 52 squared. A squared plus B squared equals C squared, right? What's the square root of 52 squared? Well, that equals 52 plus the square root of 52 squared equals 52. So that's 104. So SL squared equals 104. Now you got to square root both sides. SL equals the square root of 104. SL equals, let's find out, on second, x squared 104, enter 10.198, so 10, let's just call it 10.2. So you've got SL, got IL, and you've got SI. SL is 10.2. So the perimeter of the triangle is square root of 52 plus square root of 52 plus 10.2. So second, x squared 52 plus, wait, second, x squared 52, enter, is 7.21. So we're just going to say 7.2 plus 7.2 plus 10.2. This is our perimeter. You should get the perimeter equals 24.6. Wowzers. It's gonna be a tough test. Gotta say units. This is a study guide. Yeehaw. All right, hey, that's it. 43 minutes. Now, I have years and years and years and years and years and years of math. So, will it take you 43 minutes? Probably a little bit longer, maybe. Some of you might beat me. You never know. But it's a big test. It's worth 3 times your quizzes. 43 minutes ain't nothing. So even if it takes you 3 times as long, and even if you have to revisit it 3 times, spend 6 hours this weekend studying. You're going to have to find out that life is hard, college is hard, high school is hard. Put in the work. Go back to these questions. Did you master all these problems before taking the test? You study hard enough, it should be yes. Did you call a friend to study or ask for help once you were stuck? If you get stuck, you got to call that friend. Hey, can we go over that stupid SIL problem again? And call your best friend. Did you email Fisher with questions? Or even better, because I'm busy, watch his YouTube video walkthrough? Hopefully you watched the walkthrough. If you watched it and you spent like 45 minutes watching it, that's your first line of defense. So you go back here, 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 here. And you ask yourself, like, did you go through it multiple times, hopefully, before you just shoot off an email? I don't get it. I don't get it. Those are so annoying. I don't get it. Okay, well, did you watch the video? No? Well, then watch the video first. And then if you still don't get it, come see me. I will help you. Even if you don't watch the video, I'll help you. But you got to take it upon yourself to start taking ownership of your own learning. And you got to put in the work. All right, off my high horse. See ya. Good luck.